Hello once again, this is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for JavaScript 6th edition, the Web Warrior series by Vodnik and Gosselin, and I'm up to Chapter 11 of 12, which is on AJAX. AJAX is an acronym that stands for Asynchronous JavaScript and XML. So we've got 5 objectives here. Describe the steps involved in using AJAX to update data. Create an HTTP request and interpret an HTTP response. Request and receive server data using XML HTTP request. Process data received from a web service and add it to the DOM. And update app data using JSON-P. Now, before we start, this is my take on AJAX. You may or may not agree, and I think that what I'm telling you is right. I've never did it and had anybody come back and say, no, that isn't right. But if I go out to familyvideo.com and I find new releases, okay, and unless they've changed this, well, they have changed it. I haven't been out here in a while. But it used to be when you got your new releases, you could take your mouse and you could mouse over it and get some information about that movie. Well, it looks like it's not doing that now. All right, let's try this. Have you ever done this? Have you ever gone out to Google Maps? And when you did that, you zoom out, you zoom in, etc. All right? What's happening? The screen basically is changing without you having to do what's called a redraw of the screen. Now again, that pretty much is AJAX in action. So going back to that Hunlock archive that I told you about, there is AJAX for noobs. All right? It'll get you started. It's very short, but it'll get you started. There are also, I think his name is Jesse James Garrett. All right, I believe this is the right guy, but we'll find out. And we'll put in here AJAX. He actually had a paper, a thing that came out that was called AJAX, A New Approach to Web Applications. All right, this isn't new. It came out in 2005, and I actually believe it came out earlier than that. I think this is a rewrite. I thought it came out in 1995. I could be wrong. It's not that important. The point is, this stuff has been around for a while. So you can go out to this URL right here if you want to find out more. If you don't care, you don't care. But there it is. http://adaptivepath.org/ideas/ajax-new-approach-web-applications. I also want to mention as we get started on this that AJAX again is an acronym, asynchronous JavaScript and XML. Today it's more a word than it is an acronym because much of the AJAX work that takes place today does not use XML. Many people find XML to be cryptic and hard to use. So rather than using XML for AJAX, many people end up using JSON, the JavaScript object notation. All right, just so you're aware of that as we get started. All right, so let's get into it. Again, AJAX allows client web pages to quickly interact and exchange data without reloading an entire web page. Well, what's the problem with reloading a web page? There's actually two. The first problem that you have with reloading a web page, and you may or may not have noticed it, even if it loads fast, you get what's called flicker, when one page is gone and the other page is loading type of thing. And the other thing is if it's a page that has a lot of big images or intricate images, that could take some time. And let's face it, the average computer user is fairly impatient. So AJAX relies on a programming language like JavaScript and a data interchange format. Again, The X in Ajax is XML, but much of that that's done today is done using JSON. This all came from something that Microsoft created a long time ago called an XML HTTP request object or an XHR object. Now it was meant, it was kind of a not all that big, not that important a thing that Microsoft came up with years ago. But then someone discovered that you could use it to request and receive data without reloading the page. As mentioned, it uses HTTP, the Hypertext Transfer Protocol, to exchange data between a client and the server. So again, it's the HTTP request response mechanism. Combining this request with dynamic HTML, as it says, allows you to update and modify individual portions of a web page. So the only thing that has to be redrawn is what needs to be redrawn. All right, and they give an example here. I guess it's an example of it also, and that is if you've ever gone out to Google, all right, so if you've ever Googled and you type in here, let's say that I want information about JavaScript. I type in a J. Well, what happens? Okay, this is Google Suggest right here. When I get to the A, how it changes, the V, it changes again, the A, it changes again, the S, okay? That's Google Suggest. And that's also working to modify just that portion of the screen based on my input. So this whole thing, again, we've talked about it before. This is the same machine. The client does an HTTP request that goes to a server, which either handles it itself or sends it out to another server where it comes back to this server that has to put it in HTML and send it back to the client. So that's the standard way that this works. All right. When you're working with Ajax, it's very similar, but notice that rather than redrawing the entire screen, we only redraw the portion of the screen that needs to be redrawn. Everyone is happier with that. The lag time is less. It's more or less an immediate response. All right, it's considered to be a good thing. So, what are the limitations of Ajax? First, data requested can be located on a third-party server, but not all web servers and not all browsers support this, especially older browsers. You can use a server-side script as a proxy. What's a proxy? If I'm supposed to go to a meeting in St. Louis and I can't make it because I have class, but I send a delegate for me, and I tell them what I want them to talk about, what I want them to do, and if they do that, they're my proxy. So in this case, a proxy is a server that acts for or performs requests for other clients and servers. All right, a web service. You probably don't realize this, but today there are people who have created applications, and I don't mean just software apps for mobile devices, but I mean whole applications that can be used by countless people, countless different companies. All right, I always give this example that years ago I took a class at Fox Valley Technical College in Appleton, Wisconsin. It was a week-long class during the summer. And on the last day of class, the teacher rather, had us build a real simple interface. All right, so if you can imagine, we had a box, like a big text box here, a big text box here, so there were two text boxes and two buttons underneath them. And the idea was we could type English into the first box, click the button that said English to Spanish, and the Spanish can't think of the right word, but the Spanish of the English, all right, so we did the translation is what I'm looking for. The translated Spanish would appear in the other box, or we could go in the other direction. Type it in Spanish, if we knew Spanish, click the Spanish to English box, and the English translation would appear in the other text box. We didn't have to write much code to do that, virtually none. Instead, we used what was called a web service that was available for free online. Some web services are available for free online where people can use them. Typically, their code, if they don't have a GUI or a GUI, all right, you just use them. You make calls to them. and they provide services for you and data in response to different requests. All right. Sometimes, as it says, it requires an API key. Remember APIs, we talked about those earlier. Application Program Interface, and I equated it to like a contract. In this case, it's a contract between you and software, where the software says you can use me, and you agree to use it, but use it only in the way it's supposed to be used. Proxy scripts can be written in PHP and in other languages, but they're typically written in a back-end type of language, like PHP, ASP.NET, etc. Running AJAX from a web server, you must open AJAX files from a server. In other words, you can't do this locally. I want to show you examples of this, but to do it, I'm going to have to use a product, and there's several of them, but the one I'm going to use is called XAMPP or XAMPP. And what it does is it allows me to use my machine, my individual laptop computer, as both a client and a server. But if you have an external server, you're typically running Apache, Nginx, or IIS, which is kind of Microsoft's version of Apache. Using data, or AJAX rather, as it says, to update data involves 4 steps. You instantiate an HTTP request object. You use that object to send the request to the server. You receive the response from the server with your requested data. You process the data and put it into your app. And here is the same thing, but it's done pictorially. This is virtually the same picture we looked at back a few slides ago, right here. But we're showing it in more detail, and we're showing what's happening in each step along the way throughout the process. So here, we're using AJAX to update the data. Here, we're using AJAX with a proxy server. So here we have a single server that can handle the request. Here, the server has to enlist the help from another server. That could be a database server, for example, that this server doesn't have the database information, so it has to contact another server, which sends back the information that that original server can send back to the client. So the request is the response of you asking for something from a web server. The response is the reply from the web server. We already know what a URL is. It's a web page's unique address. It consists typically of 2 parts, the protocol, typically HTTP or HTTPS, but it could be FTP as well, and the web server's domain name or its IP address. The Hypertext Transfer Protocol, HTTP, that we've talked about before. As mentioned here, it's a set of rules for defining how requests are made by an HTTP client to an HTTP server. And it defines how those responses are returned. It's establishing what's referred to as the protocol, which is the ways of doing things. The client refers to the web browser making the request. The server is the web server, and it's what responds to. All right, so the client requests the service, the server responds to the service request. The host, as it says, is the computer system being accessed by a remote computer. HTTP was developed jointly by the W3C, the World Wide Web Consortium, and the IETF, the Internet Engineering Task Force. We're still using version 1.1, and version 2.0 is in development. I think that's still the case. Could be wrong. It's not that important. HTTP messages, as it says, the client requests, the server responds. You've heard this many times now. The client opens a connection to the server, submits their request, the web server returns the response. This is the format. Again, do you have to worry about it? Much of it is very automated. HTTP headers contain information about the request or the response. We already talked about when you use your method equal post that most of your information, rather than being stuck in a query string as it is with a GET, will be put in an HTTP header. Headers, as it says, there are generic headers used in request and response messages. All right. And what we'll see in just a minute, there are also numbers that correspond to the status of those. Cache control header specifies how a web browser should cache any server content it receives. What caching is, for instance, if I download CNN.com into my computer by typing in CNN.com and hitting enter, then I get out of the system and I get back in and open up a new window with CNN.com. The system will check, and if the page hasn't changed, it'll give me that copied in version or cached version that I had. Not a great definition, but it hopefully gets you started. Again, most common types of HTTP requests are GET or POST, but there are other ones. We've talked GET before, used for standard web page requests. It has a query string on the end. POST, the data is instead included in the message header. So here's some common request headers. For lack of better words, right now, this is actually getting a little bit heavy. This is probably more depth and breadth of coverage than most of you will ever need to know about. So here are some common request headers. Here are some common message body headers. The response messages, so if I send a thing out to the system, it's going to respond, and I can go and look at that response. Typical, if the response starts with a 1, like a 100, it means it's been received but not acted upon yet. Typically, any response that starts with 2, like a 200, means success. It means it worked. If it comes in with a 3, it says that the original server can't handle the request. It's going to send it out to another server or whatever. And if it starts with a 4, that means there's some kind of an error. The server could be down. The request could have been done incorrectly, etc. Okay? 5 is usually the server error, so 4 is something else. All right, so here's some common request or response codes. 404 is a big one. If you've ever gone out to a website and you click the link, maybe there's a link within the website to send you to another site, and it's an old link, it comes up with a 404 file not found error, because it doesn't exist anymore or whatever. 0 or more response headers follow the status line. The response is returned from a server. As it says, it can be much more involved than the original request that generated it. Now think about how you'd want to use this. And I've done programs like this before, not on my own. I've typically done them with a lot of help. We'll see if we can do something like this. But I might have an app, or a JavaScript app, an application, on not even on my phone. Maybe it's just on my laptop that I'm showing you right here. And I can go and I can click a button or do something else, and it'll go out to the. Let's look at it this way. I've got a text box. In that text box, I can enter a city and either a state or a city in a country. And I can click a button and I can get the weather. So if I wanted to know the weather in Phoenix, Arizona, I could type in Phoenix, AZ. If I wanted to know the weather in Rome, Italy, I could type in Rome, Italy, that kind of thing. All right. So again, the XML HTTP request is the key to working with this. As mentioned right here, it allows the use of, not the use of use, it allows the use of JavaScript and HTTP to exchange data between the browser and the server. Here's some of the XML request object methods. Again, I'm not at all an expert on this. You can cancel a current request. You can get the response header. You can get every response header. All right. You can open when you're sending your request. You can send it. Okay, there's other things that you can do here. You can check the status. All right, so there's a lot of different things that can be done. Again, we looked at that 4-step process much earlier in here. And we said you initiate or instantiate. Remember, you're creating an object of type XML HTTP request for the browser where the script will run. You use that object to send a request to the server. You receive the response from the server, including one of those numbers that we talked about before, and you process the data if it's at all possible to do that. So again, I'm just stepping through what's going on in here with you. All right. The XML HTTP request object originally created specifically to request XML data, but now it does a lot more. But as they say, the name has become synonymous with this, so they haven't changed the name. Most JavaScript programmers use a series of nested try-catches. We've talked about try-catches before, and I've mentioned to you with a try-catch the fact that what you're doing is you're attempting to do some code that could conceivably fail. And if it does fail, you're doing a catch because you are taking control over what happens if that request fails. Opening and closing HTTP connections can be a bottleneck in page loading. It can take some time. HTTP 1.1 automatically keeps the connection open unless you tell it to be closed or you tell it to time out after a certain amount of time. You can make AJAX programs faster by using an already instantiated XML HTTP request object. They show you code here, but it's basically just explaining what I already told you. Some of these methods that we looked at before, the open method can be used with the object. You can specify whether it's a get or a post. You can specify whether it's asynchronous or synchronous. In other words, can it be doing work or does it have to send out a message and wait for a response? All right. And that's the async. A username and a password. There's an abort method to cancel any existing HTTP requests before beginning new ones. There's a send, which submits the requests. But again, that's the way it's done pretty much with gets. It's more involved with post. So there's more work that you have to do. The response XML property right there, as it says, it contains the HTTP response. There are tools that you can run for this stuff that will dig through and show you everything that's happening in here. All right. You can assign property values to document nodes. Remember this? Remember document nodes? Remember the DOM? The document object model? All right. So you can assign the value of response XML to a variable, use inner HTML, and look at what that response was. The response value is almost always a JavaScript object notation or JSON string. So you use parse to convert that string to an object, and if you have to go the other way, stringify that we talked about before. So if stuff is synchronous or asynchronous, in other words, most, let's look. Because I always get these two mixed up, and don't ask me why, it's just two words. Synchronous versus asynchronous communication. All right. Let's just grab this. I'm going to grab that. That's fine. I'm going to bring it up a notepad here. That's fine. Paste that in. All right, synchronous and asynchronous transmissions are two different methods of transmission synchronization. Synchronous transmissions are synchronized by an external clock, while asynchronized are done with special signals. You know what? That didn't tell me diddly. So let's get rid of the communication part. There you go. This is what I'm looking for. Right. Did it also give us something about asynchronous in here? All right, that's the best one. Okay, let me try one last time, and I apologize. All right, when you execute something synchronously, you wait for it to finish before moving on to another task. Most human communication is synchronous. I talk, you listen. I get done talking, you talk, I listen. All right, that's synchronous. On the other hand, when something is done asynchronously, you can move on to another task before it finishes, such as, all right, let's assume that, I don't know. Let's assume I've got this just popped into my head, and I don't know if it's going to make any sense or not, but I've got a swimming pool, all right? And what I have to do is every time before people can jump in the pool, I don't have one, but if I did rather, every time before people can jump in the pool, I've got to test, and I've got to make sure that the chlorine level is safe, all right? So I go in and I put in something into the water to test it, or I take a sample or whatever, and you can't swim until I get that back. All right? That would be synchronous. On the other hand, if I do the test and I let you go in and jump into the pool anyway, but after the test comes back and the results, if it says the chlorine level is dangerous, I say get out of the pool. That would be asynchronous. That's not the greatest of explanation, but hopefully, again, synchronous means that you do something, you wait for it's like I request something, I wait for a response, then I go on. With asynchronous, I request something and I can go on even before I get the response. Hopefully that made some sense to you. If it didn't, sorry. Synchronous responses are easier to handle, but the drawback, the script will not continue until the response is received. Asynchronous are done with a send message, allows JavaScript to continue processing while it waits for a server response. So again, with synchronous, all right, it's as though, going back to my original communication example, with synchronous, I talk, you don't start talking until I'm done. And I don't start talking when you're talking until you're done. With asynchronous, you might say something that so inflames me that even though you're still talking, I start talking. All right? Type of an idea. Again, not the greatest, but I'm giving you some examples. Here's another code example. Again, when you get a 4, it's finished loading. That's usually a good thing. I'm sorry, when you get a 4, response of 4, it's finished loading. That's the number 4. All right? Again, 200 would mean that it's been received and it's a success message. 4 would mean the response is finished loading. So you're checking both of them. All right. Refreshing server data automatically. Automatically refresh data obtained from an HTTP server. You can do that after a certain time or after a certain interval. 2 alternative proxies for working around this same origin we talked about before, and it's not that important that you know this, but JSON P, which is JSON with padding, and CORS, which is cross-origin resource sharing. I don't know enough about this that I should even be talking to you about it. So you can look at this you can look yourself at the pictures that are in here. All right? So that pretty much brings us to the end of Chapter 11. We have one last chapter, and that's on jQuery. So in this chapter, we went over the steps involved in using Ajax to update the data. I twice went over that 4-step process. We talked again some more about how HTTP is a request from the browser or client, response from the server mechanism. We talked quite a bit about the XML HTTP object. We talked about how how you process data received from a web service. I gave you my own example. And we talked, I just skipped over the JSON P stuff. So the only thing that's left is our last chapter, which is on jQuery, and I'll be back with that shortly. I just wanted to mention one last thing before I do, and that is, if you just type in Ajax, Jesse James Garrett, you'll get a link to this if you can't remember. But it's worth reading. It's not really a big article. And there's some Q&A at the end. All right? But the article, so this is all of it right here. Through right there. So if I print that out, probably only about 3 pages. 1, 2, 3, 4 pages. All right, and I printed it out before. I'm printing it out again, and I'm going to read it again. All right, so we'll be back to talk jQuery with you, at you, in just a couple.